The main character of this video is the experimental suite of TLA-004U6 sensor course. TLA-series sensor course experimental suite is developed and deployed based on virtual instrument technology. The in-class experiments based on virtual instrument technology are not only suitable for the sensor course, but also suitable for the main courses of engineering education, such as circuit principle, analog electronic circuit, digital electronic circuit, signal and system, automatic control principle and so on. TLA provides complete laboratory application solutions for these related courses. In-class experiments based on virtual instrument technology are inseparable from the following three aspects: the use of instruments, the use of experimental kits, and the operation of experimental software. TLA-series course experiment suite can completely provide specific experimental contents that meet the above three requirements. TLA-004U6 sensor course experimental suite has greater flexibility in the selection of virtual instrument hardware, and it supports MIO Series B series USB data acquisition cards, such as USB-6009, USB-6001, USB-6002, USB-6003 and other models. What you see in the end picture is MIO USB-6009, which is an instrument used in the experimental suite of TLA-004U6 sensor course. It is a hardware device. MIO USB-6009 is a data acquisition card with USB interface suitable for industrial training, education, and teaching applications. It has the functions of analog signal input and output, digital signal input and output, and counter, and the driver natively supports MIO DAQ. It is a model with multifunction data acquisition ability and high-cost performance. MIO USB-6009 can provide 8-channel single-ended analog signal input or 4-channel differential analog signal input, 2-channel single-ended analog signal output, 13-channel digital signal input and output, and 1-channel counter function. Furthermore, the combination of TLA course experimental suite board, MIO USB 600X data acquisition card and experimental software DAQ can provide the functions of experimental analysis instruments related to specific experimental contents, such as dual-channel oscilloscope, dual-channel function signal generator, dual-channel programmable power supply, Porter diagram instrument, etc. The functions of the above instruments are all based on virtual instrument technology, which is bound to the LabVIEW development environment. It can be used directly in DAQ. Standard API interface functions are also provided for secondary development of programming. The video picture is the body of the experimental suite of TLA-004U6 sensor course, which is a blue board base. In its upper left corner is the interface connecting MIO USB 600X data acquisition card. Place the logo screen face of USB 6009 data acquisition card upward, and place the USB interface to the left. Insert the interface at the bottom of USB 6009 into the interface at the upper left corner of the TLA-004U6 board base to complete the connection between USB 6009 and TLA-004U6 sensor experimental kit board. If you want to remove the TLA-004U6 course experimental suite board or replace it with another model of TLA-series experimental suite board, you can hold the acquisition card and experimental suite board with your left and right hands respectively, and at the same time, apply force to the outside to separate the acquisition card from the experimental suite board. What you see in the picture now is that the experimental suite of TLA-004U6 sensor course has been connected with USB 6009 data acquisition card. Next, find the dual Type-C cable and Type-C port power adapter in the package. Insert the plug at either end of the dual Type-C cable into the Type-C socket on the outer side of the middle and upper part of the kit board. Insert the plug at the other end of the double C line into the power adapter of Type-C port. Plug the Type-C port power adapter into the main socket. Turn on the main socket switch. At this time, it can be seen that the 3 power indicators in the middle and upper part of the kit board will light up immediately. The voltages of these 3 DC-regulated power supplies are plus 5V, plus 12V, and -12V respectively. Their terminal is located in breadboard on the right side of the power indicator. The required power supply can be connected to the specific experimental circuit through wires. The terminal of the two-way programmable power supply is located on the left side of the power indicator light, that is, the fifth breadboard of the experimental suite board. The terminals are labeled VPS0 and VPS1 respectively, and the voltage output needs to be set in combination with the experimental software DAQ where the DC voltage output ranges of the two programmable power supplies are 0 plus 10V and 0-10V respectively. The maximum current driving capacity of each channel is 200 mA. Next, connect the USB data acquisition card with the computer. One end is a Type A flat port and the other end is a Type B square port. First insert one end of the square port into the Type B USB socket on the left side of USB-6009. Insert the USB plug with type of flat mouth at the other end into the USB socket of the computer. Complete the connection between data acquisition card and computer. Next, follow our camera and learn about them one by one. In the upper left corner of the board, there are two 3.5 mm stereo audio interfaces, which are used for the input and output of audio signals, and are associated with the first breadboard terminal to realize seamless link, acquisition, and data processing of audio signals. One hashtag module is an experimental module for measuring the characteristics of 5 basic photoelectric sensors. The 5 basic photoelectric sensors are photoresistor, silicon photocell, photodiode, phototransistor, and pin photodiode. The experimental module provides the measuring circuit, high illumination light source, and supporting light source control circuit required for the experiment of 5 basic photoelectric sensors. During the experiment, the complete experimental process control of basic photoelectric sensor characteristics can be easily realized by combining the experimental software DAQware for NI-DAQ-MX. 2 hashtag module is several amplifier modules used in sensor signal conditioning circuit. TLA-004U6 sensor course experimental suite provides non-inverting amplifier, inverting amplifier, fully differential amplifier and voltage follower with adjustable gain, and students can flexibly apply the amplifier to sensor signal conditioning. In addition, the sensor bolt terminal with DC bias can be provided. The combination of human pyroelectric infrared sensor and inverting amplifier can form a signal conditioning circuit that meets the characteristics of human pyroelectric infrared sensor. During the experiment, the experimental software DAQware for NI-DAQ-MX is combined to help students master the working principle and characteristics of the pyroelectric infrared sensor for human body. Combined with LabVIEW programming, we can participate in the whole process of the sensor experiment. 3 hashtag module and 4 hashtag module are experimental modules for DC motor speed measurement. Among them, the 3 hashtag module is an experimental module for DC motor speed measurement based on groove optocoupler. For hashtag module is a DC motor speed measuring module based on Hall IC. Slot optocoupler is a kind of photoelectric sensor, and Hall IC is a kind of magnetoelectric sensor. The 2 experimental modules share a DC motor, which provides the rotational speed signal for the rotational speed measurement experiment. 3 hashtag module and 4 hashtag module provide 2 schemes for measuring the speed of DC motor, which helps students to understand the principle of measuring the speed of motor with different sensors and the related knowledge of conditioning circuit. In addition to measuring the speed of DC motor, with the help of LabVIEW PID toolkit, 3 hashtag module and 4 hashtag module can realize the speed control of motor rotation by 2 sensors. 5 hashtag, 8 hashtag, 9 hashtag and 10 hashtag modules are modules for temperature measurement experiments of various temperature sensors. Let's look at the 5 hashtag module, which is used for the temperature measurement experiment module of the thermistor temperature sensor. Thermistor temperature measurement experiment using negative temperature coefficient, combined with the onboard heating and air cooling device. The temperature measurement and temperature PID control experiment of thermistor based on negative temperature coefficient can be realized. 9 hashtag module is an experimental module for temperature measurement with integrated temperature sensor AD592. AD592 is one of the commonly used high-precision integrated temperature sensors, and its output current is linearly proportional to Kelvin temperature. Combined with the onboard heating and air cooling device, the experiment of temperature measurement and temperature PID control based on AD592 can be realized. Combined with LabVIEW programming, students can fully participate in the whole process of temperature measurement and PID temperature control experiment of AD592 integrated temperature sensor. 10 Module is an experimental module for temperature measurement with integrated temperature sensor LM35. LM35 is one of the commonly used high-precision integrated temperature sensors, which is different from AD592 in that the output voltage of LM35 is linearly proportional to the temperature in Celsius. Combined with the onboard heating and air cooling device, the temperature measurement and temperature PID control experiment based on LM35 can be realized. 8 Module, which is the heating and air cooling device on board the experimental suite, is the key to ensure the temperature control experiment. In addition to the temperature sensors described above, the experimental suite of TLA-004U6 sensor course also supports thermocouple temperature measurement. Thermocouple is one of the most widely used temperature sensors in industry because of its wide temperature measuring range and low price. The temperature measurement experiment of thermocouple temperature sensor can be carried out by combining 2 to 4 module with 9 module. 2 to 4 module is a differential amplifier module, which is a fully differential amplifier. 3 kinds of settable amplification factors are provided to meet the requirements of high-gain amplification of weak signals. In addition, the fully differential amplifier of Module 2 to 4 is specially designed with a pre-filter, which can be seamlessly connected with the thermocouple temperature sensor to ensure reliable signal conditioning during thermocouple temperature measurement. The cold-end compensation of thermocouple is an unattainable technical link in thermocouple temperature measurement. TLA-004U6 sensor course experimental kit provides high-precision integrated temperature sensor, which can be used as cold-end compensation for thermocouple temperature measurement. Combining the onboard heating and air cooling devices and the open LabVIEW programming environment, students can fully participate in the whole process of thermocouple temperature sensor temperature measurement and PID temperature control experiment. 12 Module is a bridge conditioning circuit module, which provides a bridge structure circuit required for strain measurement. Through configuration and setting, the full bridge, half bridge and quarter bridge structure can be flexibly realized. More specifically, the TLA-004 sensor experiment kit provides a double-hole cantilever structure on board, located in the 11 module. This structure provides the same cantilever beam structure as the industrial weighing sensor, with 4 strain gratings of the same specification built in, and provides a complete 8-wire connection. It can be flexibly combined with the bridge structure in the experiment to meet the needs of various strain measurement experiments. The kit also provides weighing weights, and combined with the experimental software DAQ for DAQ, the verification of experimental measurement data of metal foil strain gauge characteristics is completely realized. 6 Module is a passive filter module which is used for signal conditioning of sensors. Combining with the noise in the actual measurement experiment, the signal quality of the conditioning circuit can be optimized by using the filter reasonably. There is also a breadboard area in the middle and upper part of the TLA-004 sensor course experimental kit. This area is used to build sensor modules, single-chip computers, or embedded minimum systems other than onboard sensors, such as electret microphone sound acquisition module, relative humidity measurement module, relay module, Arduino development board, STM32 minimum system board, FPGA minimum system board, etc. With the support of customizable sensor module, combined with the experimental software DAQ for DAQ, students can broaden their experimental horizons and enrich the application of TLA-004 sensor experimental suite. In the following video, we will explain the experimental application case of the TLA-004 sensor course experiment kit through specific experimental projects, and the experimental software DAQ for DAQ.